Hello everyone, welcome to a final presentation of Team Scansat. We're happy to present our project to you all. But first, our team. We are from the SMSI-scholen IRIS, but our team is from two different campuses, from two different years, and we all follow different courses. So that wouldn't be so good for teamwork. But luckily, we had the opportunity, spirit, curiosity, and perseverance to work together for this presentation and competition.
So everyone in our team carries out specific tasks. Jules here makes sure we have a connection with the ground station. He made the ground station, he made the antenna. He also does a big part of the coding. Mari has done a lot of the camera calibration and data processing. Timon does lots of code. He does the camera calibration, the data processing, and he also overviews the whole team and makes sure things get done and we are on the right track. He also has most knowledge of these things. So we are very thankful. I do the mechanical and electrical part of the Cansat. I helped build it and yeah, that's basically it. We make sure everyone overlooks each other's tasks on the project, so when there is help needed with someone else, we can always switch persons and everybody knows what's going on basically.
So for the primary mission, everything went fine. So all the data was collected from our sensors and our antenna was working, we received data. But the day before, in Elsenborn, we had a lot of trouble with our antenna. When we were in Iber before Elsenborn, we did a range test for 600 meters and that worked with ease. But when we came in Elsenborn, we barely had 100 meters, so we kept looking the whole afternoon. Also the engineers Sibo and Aditya helped us, and the team Satinia, thanks a lot. It was such a huge help, but we weren't able to fix it in the afternoon, so we kept looking in our room, in the dormitory, and we tried unsoldering things, soldering it back, everything that we could, and after 12 p.m. we were able to solve it, but we don't know how it was fixed, but it was fixed, so it's good. The following graphs are also with the telemetry data.
So all the things you see from the graphs is the data from our antenna. We will start with the air pressure. You can see that in the beginning it drops, and that's good because when you go higher in the sky, the air pressure drops. And after a while, it increases again, so the Cansat goes back to the ground. For the temperature, the same story held in the beginning. It drops because when you go higher in the temperature, it's lower. But the difference with air pressure is that now the temperature stabilizes around 30.9 degrees. Lastly, we will discuss the altitude. The blue points are for the barometric altitude from our pressure sensor, and the orange points are our GPS altitude from our GPS. So the altitude increases, and after our apogee, it decreases again with velocity. Our descent velocity was around approximately minus 10 meters per second. That's higher than we calculated and tested before. Because just before launch we added glue and tape and lead to our Cansat, that's IRIS, and that leads to also a higher velocity. Our maximum altitude above sea level was around 1,300 meters, but when we compare it to the point where we launched, our maximum altitude was around 750 meters.
Our secondary mission was to make a map using pictures we took during the flight, but we did not retrieve our Cansat, so we weren't able to do any photogrammetry. Well, I'll quickly explain how it works. So we take the pictures from the air, that it's a video actually, and then you split it up into frames, put it into software called Mushroom that does the photogrammetry for us. Then after a lot of processing time, you get a 3D model. It's that 3D model, then we put it in our own software in Python. It takes all the vertices and puts it in another file and then gets read in processing, where the graph is made. The darker the color, the lower the altitude, and the higher the color, the lighter the color, the higher the altitude. We were quite pleased with our tests. As you can see, fences and branches in the trees, and also tractor tracks, but I probably mentioned that in the semi-final. That should have been like that. And we did a fully integrated test. You can see the model is a lot worse, but that's because we only had 13 frames in the descent. It's only a drop of 15 meters, so we couldn't get enough data. It's actually a wonder that it actually made a model. Last night we made our own landscape and made a video using a towel and some a box. This is how we imagined our data to be, but the landscape was way more exaggerated than Elsenborn would be. And then this is our graph that we created using the video we took.
So for our mechanical and electrical design of our Cansat, we had some trouble, I shall explain, with the radio, but that got fixed at the right moment, so the night before. At the launch site, we made sure we were ready for launch. We had a pre-flight procedure, a whole checklist we had to do so we wouldn't forget anything, any crucial steps. We made sure, we already explained in the semi-finals that our construction, we were very confident of our construction. We think it's like sturdy. But we helped with every wire. We made sure everything was soldered correctly. We put our battery in our Cansat, and now you will look at the pictures and you would say, where's the battery? But the battery is actually located in between the electronic plates of our Cansat. We have a very big battery. It's like half of the weight of our Cansat. But that's because last year Timon and Jill participated, and we had a lot of problems with the battery. It disconnected before launch, and we didn't have any data. So we made sure we had a good battery with a nice battery controller, so it would cause any problems. So we made everything ready for launch. We tested the parachute cords, we taped everything so it wouldn't get too wet. We made some holes for the in front of the PDB so we could have pressure, and made a hole for the antenna.
So we're happy to say that we reached over 1,300 accounts on Instagram and Facebook. They're facing weekly posts, and we also yesterday VTM came to Elsenborn and we were also interviewed by them. We are also going to be on our open school day, and we are going to present the Cansat. And as we have Teachers Makerspace, also we post our weekly posts so we get even more exposure.
Lastly, we want to thank a lot of people. We want want to thank, of course, Isil for it helped us with our antenna, of course, here's we want to thank and Team IRIS for launching our camp. We had a lot of fun, and I hope also learned.
So computer, come here to the center, and let's see if the judges have questions for you. Do you have anything you would like to ask this team? Yes.
Alright, thank you for work. Now, with the graph of the altitude, the GPS and the pressure, why do you think there's a sudden drop of GPS altitudes compared to the direct altitudes? We had a little problem with our GPS. We didn't have any, we didn't have enough, we didn't set the decimal points at the right place, so we didn't have any points, any numbers added to the decimal points, only two numbers. But we basically have like these 4 points that are on the right track, and these 3 are just random. We think the GPS is just like, ooh, what's happening? So, yeah, we couldn't figure out what that is.
Thank you. Any other question for Cansat? Yes?
So congratulations for your work. I have a question about the program you use. You say that you have to have make picture to be accurate enough. Do you know maybe what variable is using your program, and how can you what is maybe the limitation of your program except the number of data? Is working, for example, in any kind of field?
Software Mushroom uses takes the picture and then extracts a lot of features out of the picture. We set it to 20,000 or a maximum of 20,000 features in every picture, and it tries to match those features with another feature from another picture, and then the mushroom calculates the relation between the camera positions. That's the feature is a main part. We can also give in the GPS coordinates, and it can reconstruct the 3D map easier than, but we can do a test that if you didn't have GPS for camera. But the amount of pictures the amount of pictures is the most important one. The first test, that was 179 pictures, that was 13 I believe, and this was 97. At home we tested it to 500, and then they were very accurate, so we tried to aim between 200 and 500 pictures. We got data and it said that we were at frame 3000, so we could have, if we have reduced, we could have extracted some frames to have enough for mesh to.
Thanks a lot. I think you're ready to go, so you may go back to your seats.